Okay, so yeah, it's a pleasure for me to be here, to stand in front of you. Today I want to spend 40 to 60 minutes telling you a little bit more about partitioned views. Partitioned views is only something I've checked quite recently when I really had an issue which could not have been solved using partition. But let me discuss this a little bit in the next minutes. So what I want to do is I first want to give you a short introduction. Who am I and what I'm going to talk about? And then we basically go into partitioning. So we do not start with partitioned views. We start with what is partitioning and then move into the topic, what is actually wrong with partitioning? So what are the issues with partitioning that made me move away from partitioning and do something else? And then we talk a little bit about what is a partitioned view and how does it actually work, and move into some use cases. I am unfortunately not able to do demos on live data because in order for partitioning or partitioned views to make sense, you need millions of records. So I've built up a demo environment with 110 million rows in a fact table to do some demos, which I will show you in screenshots or through Azure Data Studio. I will also first go through how I create my demo environment, because if you want, you can get all the demos and do it yourself, either at work or at home, where you prefer. And at the end, we should have some time for questions, and I would be very happy if I would also be able to answer your questions. If not, I'm sure we can take it offline and answer it another time. Okay, so first a slide about me. I'm not going to read what's on the slide. So basically, I'm a premier field engineer at Microsoft for the data and AI domain. And without going into my focus, let's just say I have a really good time if I'm at a customer. The customer comes to me in the morning and tells me, this query is slow, what can we do? That's a good time for me. It's a very bad time for me if the customer tells me, this query is slow, but we cannot change the query. But I think you all know this feeling. Okay, so the second one is a little bit important to me because I am a beginner public speaker. So this is my first time at the PAS, and I will also be at SQL Saturday in Iceland. So be kind. Everything else you can basically see there. Enough about me. Let's get into the presentation. So my goal is for you to learn a little bit about partitioning, to learn a little bit about partitioning views, and also learn a little bit more about check constraints. So with a slideshow of hand, who has used partitioning? So 80%. Who has used partitioning in the last 90 days? Around 30%. Who has used partition views? 2, 3 hands I can see. Okay. And who is using check constraint quite often? Close to the same amount. Okay, that's very good. And I mean, if we still have time during the session, at the end or after the session, I would be glad to share some experience if someone wants to talk afterwards. Okay, so let's dive into the partition topic. So what is partitioning? Partitioning is basically nothing else than the process of dividing the data into subsets, into partitions, or other kind of forms. And there are actually two kinds of partitioning: the horizontal partitioning and the vertical partitioning. The vertical partitioning we do quite often, but we don't really recognize it as partitioning because that's what we call vertical partitioning. You have a huge table with a lot of columns, and it takes up terabytes of disk space, and the customer tells you it's just too much data. We need to add more memory. We need to add even more memory, memory. Then you need to stop the customer. We need to stop the customer and tell them, listen, maybe we can just minimize the amount of data you store. And the vertical partitioning is nothing more than simply normalizing your data. And I've seen quite a few customers where this was the solution to all their performance problems. Simply getting some of the columns out, which were repeated multiple times. For example, we have a product description, which is stored with each fact entry over and over again, which can be 204 or 400 bytes. This takes up a lot of space, so let's get rid of this. But today we're not really focusing on vertical partitioning, we're more focusing on pizza. Because I was thinking how to better explain partitioning and partitioned views than choosing to talk about pizza. I mean, the slide previously from Stein, where he was showing the disk layout, really reminded me of pizza, so this helps as well. But bear with me. Let's say a week ago there was the Super Bowl. Everyone watched Super Bowl? Some, not that much. But let's say you make a big party. So you invite 20 people to your party, and you want to make pizza. So how do you make sure that everyone gets the pizza at the same time? You could either do it like this, so you create a huge pizza and slice it up. So you create partitions out of your pizza. So that's the SQL Server partitioning you all know and you all love, or hate, depends on the experiences you had. So SQL Server partitioning is actually described in the docs.microsoft.com as data of partitioned table and indexes is divided into units that can be spread across more than one file group, or can be one file group. That's the simple definition. So you take your table, you take your pizza, and you slice it up, and you store it either in one location or in multiple locations. Just some more facts about the partitioning here on the slide. It was available only in Enterprise Edition until SQL Server 2016 Service Pack 1. Since then, it's available in all versions. There's currently I think it's a soft limit of 15K partitions you can have. If you reach this, I think you're pretty far with how the partitioning works, and I think you might hit some pitfalls, but that's where it gets interesting. Okay, so we now saw the SQL Server partitioning, but what is a partitioned view? A partitioned view is you're not going to create one huge pizza. You're going to create several smaller pizzas and store them wherever you want. You're still able to slice the pizzas, the smaller ones, but you do not have to. And what you then do in SQL Server, you create multiple tables which store a subset of your data. So if you have a fact table that normally has 10 years of data in it, create 10 tables with 1 year of data in them. You can distribute those into different file groups. That's no problem. You can also create multiple tables and have partitioning on the table itself. There's no limitation there. But that's basically the partitioned views. You just create a view, and then you select from all the tables and combine them using union all. That's close to all that's required. What's also required is a check constraint, because you need to tell SQL Server, the query optimizer, what kind of data SQL Server can expect in which table. So you're creating a check constraint on each of those tables and tell SQL Server, listen, the table fact 2018 only contains data from 2018, and so on. So that's basically the whole magic. But before we talk even more about the partition views, let's step a little bit back and think about why we use partitioning. So I saw a lot of people that use partitioning. Can we have a few reasons why you implement the partitioning?
Table maintenance.
Table maintenance?
Window partitioning to load data.
Loading data quickly and so
Archiving.
archiving and loading it in. The third one? Okay, let's leave it here. So that's pretty awesome that we heard those reasons and not the one that's on the right. Because what I hear often from customers is we need to implement partitioning because of performance. And performance can be better with partitioning, but more often than not, it's actually not really helping. So the best reasons is really to be able to transfer data in and out very quickly. The second reason, it's what we heard first, is maintenance. With partitioning, we're able to, let's say, reorganize our indexes by partition. If you have partitioning, you normally have the partition key being the date. And normally the data you have from 10 years ago doesn't change anymore, or at least it shouldn't. So all you have to do is reorganize the index from the last few months, which can be achieved a lot faster than having to reorganize an index over 10 years of data. Okay. The third one is quite an important one in Switzerland, for example, in the financial services, where we have some compliance regulations requirements. So you are required to archive your data and make it immutable, so read-only. What you can do with partitioning is define some file groups as read-only and archive the data you want into this file group using partitioning. And the last one is sometimes performance. As I said before, performance can improve, but this really depends on the kind of query you're executing. Okay. So what are some issues with this partitioning? We saw very good reasons to use partitioning. What are the limitations, or what are some issues? The first one is performance. Even though performance can be better, it can also be worse. We had a very good presentation before about indexes, and you can remember we saw the B tree, the balance tree of, let's say, an unclustered index or a clustered index. If we have a partition table and we create an index on another column than the partition key, let's say we have a table which is partitioned by the date, but we also have a product ID. Now we go ahead and create an index on the product ID. There is a B tree created for each of the partitions. So no matter how many records will come back from your query, you at least get the amount of partitions as number of scans, at least. And that's no issue if you have 4 partitions, it's no issue if you have 10 partitions, but if you have 15K partitions, this really hurts performance. So if you're planning on doing a lot of select queries where you do not specify the partition key in the where clause, most likely your performance will be a lot worse. Okay. Another issue with SQL Server partition, which I found, is that the partition key needs to be a single column. So you either partition by product or you partition by date. You're not able to partition by both, something you can do with partitioned views. The third one, DBCC CheckDB takes increased time, especially in BI workloads where we have terabytes of tables. DBCC CheckDB time is really crucial. And with partitioning, this even goes up. There's even a issue if you have read-only partitions that DBCC CheckDB doesn't run on the table. You first need to create a snapshot, which is additional effort. So your, let's say, minimized administration go through the roof. The second to last is no mix of clustered indexes. So even if you partition your table, you only can have one clustered index. So you're either going to have to use a column store index or a row store index, a normal clustered index, but you're not able to mix this. And this will at the end lead me to the reason why I use partition views actually. And the last one, and it's also the reason why I first asked who has implemented partitioning in the last few days, 90 days. For me, every time I need to set up partitioning, I first need to look it up. I first need to go through the steps. I first need to create a demo before I can really do it. So for me, it's not something you do every day. And complexity really isn't something that we should look for. So those are some issues with partitioning. And let's move on about, and talk a little bit more about the partition views, which can solve most of the issues we just described. So that's repetition. We have a view combining multiple tables using the union all. Quick check. Who knows the difference between union all and union? Everyone is aware of this? Okay, very good. So everyone. And then we just create the check constraints. That's basically it. Then you have your partition view, which sounds a lot simpler than actually creating it because we're working with millions of records, sometimes even billions of records. Okay, so what is the advantage of partitioned view? And I mean, I highlighted my biggest one. It's easier to understand for me because I'm just dealing with tables. I know what I can do and what I can't do with a table. It's very easy. And you can also have different columns, something you cannot do in partitioning. So this happens actually quite a lot. You have a BI system, you have a data warehouse, and you check it the first time, and then you see a lot of columns which are null. Then you ask the customer, what are those columns? Why are they null? And they tell you, well, listen, 10 years ago we had another ERP system, and this ERP system was delivering those fields. And we do not want to get rid of those fields for the archiving purpose. So we just let them be null. Just, I mean, it's a solution. But with partition views, what you can do is you do not need to have the same columns in all of the tables. You can only select a subset. Another big advantage is that you will have statistics by subset. If you have a partition table, and you have an index, you will have one statistics over all of your billion records, where the sample rate is definitely smaller than your billion records. With partitioned views, you have statistics with a lot smaller subset of data, which helps the query plan, which helps getting better query plans. Another one, which I haven't really used, but read about, is to be able to hide table names. If you want to expose your data, but you want to make sure that that your, let's say, customer of the data warehouse, that they are not aware of the underlying data table names, you're able to hide it using a partition view, for example. Last but not least, like I mentioned before, for me, it's just easier to understand. And that's basically, those are the advantages. Plus, I want to add the third one, which I haven't mentioned because it was the reason I actually got into partition views, is the index by subset. So you can have a mixture of column store, row store, and in memory, all inside of one huge fact partitioned view, which helps a lot with a lot of use cases. For example, if you have real-time streaming data. So what are some disadvantages of partition views? I mean, it's not all awesome. There are also some issues. First one is adding and removing new tables. As we heard before, one of the reasons to use partitioning is you're able to get data in and get data out very fast. With partition views, you're technically as fast as with partitioning, but it requires altering a view, which is always some kind of a hassle. It might be faulty to configure because you really need to make sure that your check constraints do not leave a gap. And you need to make sure that they are open on both sides if you want your partition view to grow. Otherwise, you might have issues with inserting data, updating data inside of your partition views. The other one, what I just said, you can make your view updatable. So SQL Server knows if you insert data to which table it needs to go, but this requires some additional work. Like you need a primary key, which in most cases you have. You are not allowed to have an identity column, which in most cases you do have. And you need to have the identical columns and expose all the columns in the view. So one advantage we just said, just like before, goes down the drain if you want to use an updatable view. Okay, so I saw a few hands that said they used partition view before. Was it updatable or non-updatable? Both, yeah. Normally, I would go with just insert and update data in the underlying tables because you save a lot of errors, but it is still possible. Okay. So that was actually it with the theory. So we're going into some demos. And the first demo I'm going to show you is how I create my test database. I'm going to show this because I've got asked a lot, how do you create a database that makes sense to really test? And I also want to showcase another thing. It's the Azure Data Studio notebooks. So show of hands, who has used Azure Data Studio? Around 25%-ish. And who has used Azure Data Studio notebooks? 2, 3. And Stein is for sure holding his hand up. Okay, so in that case, the thing with this one is it never shows up if you alt tab. Not sure if you've noticed, but it gets me all the time. Okay, so that's Azure Data Studio, and that's an Azure Data Studio notebook. Who has worked a little bit in data science with Jupyter notebooks? Same concept. What you have here is a notebook where you can have sequential text and code, which you can execute and also save, which stores the result in it. So it's very good for doing presentations, because if you have a query that takes 1 hour, you cannot do it during a presentation. But what you can do here is you can show what would be the result. Okay, so like I said, we can have some text. So I have text in here and code in here, and I will make those available. Not sure how we can do that.
Yeah,
you let me know. Okay, so first we just go ahead and create a database called Partitioning. We make it a 10 gigabyte, that doesn't really matter. And then what I want to show you is this function called rand. Everyone knows what rand does? Rand returns a number between 0 and 1, excluding 1. So if I'm calculating rand times 2, cast this as an integer, it will give me numbers between 0 and 1. Then I add 1, so this will always give me a number between either 1 or 2. This is important because I'm going to create a dynamic data warehouse where I don't know how it ends up, but I want to have the values dynamic. Okay. As a next step, I create a date dimension. We do not need to go a lot into detail here, so we created a date dimension, and then we add data for January, February, and March of this year. So that's actually a nice little trick here. If you ever want to create a date dimension and you do not want to add the dates by yourself, you can use something that I call a recursive common table expression, which uses the table expression to always subtract 1 day. And then you basically get what you see below here, all the dates between January 1st until, what is it, March 31st. Okay. So I create quite a few dimensions. Here I also create a dimension called country with Switzerland, Austria, Germany, and Iceland in it. I create a product dimension. I was actually on vacation while creating this demo, so I have gin, whiskey, and rum with the prices. And then we also have a sales channel. So did we sell the alcohol through social media? Did we sell it through stores or an online shop? And then we have our fact table. And this might be interesting for some of you, not really related to partition views, but to see how I can actually fill this. So inserting data, I use this rand feature to generate a value between 1 and the maximum of the ID of each of the dimensions. That's not very important here. For the quantity, I also have some kind of of helper with a modulo function to make sure that I have more sales with 1 and 2 quantity than, let's say, with 8 quantity. But that's not that important. I generate this, and at the end, I'm just going to insert into the fact table and use all my values I just generated above. I execute this. I executed actually 110 million times, which took quite some time. And I want to show you a little trick. If you need to do something with go 1 million time, make sure to use a begin transaction before you do it, and then a commit afterwards. Everyone knows why? Someone wanna try explaining? It's actually like 100 times faster. The thing is, if I say begin transaction, I'm telling SQL Server, listen, now I start something and you do not need to care about what I do for each of those, because if I roll back, I'm going to roll back to this point. So SQL Server in the transaction log only logs what I'm doing here once for this 110 million times. And after that, I'm still able to roll back or commit. If I do not use a begin transaction before and a commit afterwards, it will log all of those 110 million inserts, which is a tremendous overhead. So if you're going to do something row by row, always make sure to have a begin transaction and a commit afterwards, or a rollback if you prefer. Okay, so that's actually how I created my data warehouse. Not sure if this was of interest, but I'll make sure to share it if someone is interested. Okay. So the next thing I'm going to show you, I've created screenshots. It is how to create a partitioning, because although most likely all of you have created the partitioning before, I'm pretty sure it might be a little bit shady how to actually do it, right? Okay. So what we first do with partitioning is we create a partitioning function where we specify a range. So this partitioning function actually defines what are the partitions and what are their boundaries. And we can do this. We can do this using a range right or a range left. Everyone knows the difference between range right and range left? I see Tom thinking, okay, I did it a month ago, so what's the difference? It defines to which partition the actual boundary belongs to. And that's a very, very, very important point, because by default, range left is specified. And if you have range left, let's see the example. We have 2019-01-01. So the 2019-01-01 belongs to the left boundary. So the first partition will be everything smaller or equals January 1st. The second partition will be greater than January 1st and smaller and equals February 1st, which is horrible because the first of your month will always be in a different partition than the rest of your month. So make sure to always use range right if you're going to create a partition. But I hope after this presentation you're going to use partition views. Let's see about that. Okay. Then after we have created our partitioning function, we create a scheme, partitioning scheme, which defines where the partitions are actually stored. So the easiest one is to specify, okay, everything just goes into primary. So we're not splitting it into different file groups. It gets more tricky if you're going to specify the file groups. So the first partition will be in test 1 FG, then test 2 FG, and so on. And if your partitions grow, this can get quite complex. Like I said, 15K partitions equals 15K file groups equals 15K files at least. which can hurt your SQL Server, but does not have to. Okay. Okay. After that, everything we have to do is basically define an object that gets partitioned. So here we have our fact table. I call it fact table partitioned, so I do not forget which one is partitioned. And at the end, I just define, okay, this is partitioned by this scheme, and the partitioning key is my date ID. Right. That's all. After that, I can add data into the table, and it will be partitioned by the boundaries I've defined. Setting up partition views is actually quite easy. First, I need to manually partition the table into different tables. So I just specify select into with the boundaries date ID bigger or equal to, and so on. So here I have 3 months of data, so I'll just create 3 tables. Normally you would have much more, but for the demo purposes, I already had enough data, so that's more than enough. And then we go ahead and create the view, which we call here f fact sales partitioned view, and combine them using union all. And last but not least, we need to make sure that the SQL Server engine does know what kind of data is in which table. So we alter each table and add a check constraint. So we add a constraint, which is a check constraint with all the boundaries here. And then let's do a little test. So we can actually execute the same query over our normal table, which is a heap. We all heard what a heap is before, on our partition table and on our partitioned view. So which one is most likely going to be the fastest? Number 3, because I'm giving a presentation of partitioned view. Some other guesses?
The heap table.
Not one. Okay. So fastest is number 2, followed closely by number 3. Fastest in terms of time, but still a little bit more resource intense because partitioning always, well, the second one is the partitioning always adds a little bit of CPU overhead. But number 2 and number 3 are equal in performance, let's say. They all did a table scan. And if we move back just once, what we're selecting is the first 10 days of the month. So both partitioning and the partition view were able to eliminate the actual data that gets returned. So the first one, it needed to scan through all the data. The second one needed to scan only through partition 1. And the third one only needed to scan through one table. What you can also see here is what I mentioned previously. So the second one got, what's that, 760K records out of 2.3 million it actually estimated to be returned. So the estimates were actually pretty off for the second one. And that's the issue we have with the statistics, because statistics in partitioning are created for the overall table. For the third one, partitions are statistics are created by table. So it had a much better estimate of how many records will come back actually. Okay. Example number 2, we're going to create some clustered indexes, pretty straightforward, just a clustered index on the date ID, on all of them. And we go ahead and execute this again. Which is going to be the fastest? Exact same query, but now we have indexes, clustered index on all of them. So we want to guess. The third one? Another guess?
First one.
The first one? Okay. It's actually, all of them are pretty close. Because that's another message. Like I said before, it really depends on your query. If you're going to execute something that does an index seek, what we have over here, it doesn't matter if you have partitioned or not. Index sig will always, mostly always, perform the same. Okay, then we're going to look at inserting, updating, and deleting records in a partitioned view. I've prepared a Azure Data Studio notebook for this as well, because this one is actually pretty tricky. And I left a lot of mistakes in there to really show you the limitations there are. So first of all, I'm going to just specify use partition. A short question for the ones behind. Is it big enough to read, or should I make it a bit bigger? Bigger? No, it's okay. Okay. And I just check how many records I have in my partitioned view, in my table for January. So we have around 37 million records. No, that's even, yeah, 37 million records. And at the end, it's a 6. So if we're going to add something at the end, it should be a 7. Okay, and then we simply specify insert into our view our values. Then we get an error, and I think this is a little bit small to read. Union all view is not updatable because a primary key was not found on table. So I have a table, a fact table that can have duplicate values. So I do not have a primary key, so that's a bummer. So we're going to add a primary key. We alter table, add ID int identity with the constraint that it is our primary key. So this adds the identity and counts up for us. So we just let this run, go. Okay. Sorry. No worries. We just execute this and go ahead and drink a coffee. When we come back, it might be done because it needs to iterate over all records. Okay, let's say it's done. Then we try to insert again. Next error. So what might this be? It is not updatable because the primary key of table is not unioned with primary key of predicate tables. Okay, so that's a following error. Another error I first got was it cannot be an identity. So, well, how do you remove an identity column? Or the identity flag of a column? Someone knows? It's pretty straightforward. You just drop the table and recreate it. There's no other way. If you're going to use Management Studio to remove the flag, it's going to tell you, okay, I will save this, but this requires me to drop the table and recreate it, which will most likely run into a timeout. So what you can do is you script out the change, and what you can see is it just recreates a table without the identity and just insert everything into it. So that's the easiest way to do it. And then I thought, okay, what else now? It was around 10 o'clock at night, and I was thinking, what other errors could I actually get with partition views? And then it came to my mind that there is a table called sys.messages in SQL Server that stores all the possible error messages. So if you ever want to know what could go wrong, you can query this. And what I did is I didn't make it searchable, so that's on me, but I tried to get everything in there that could go wrong. So let's go down here and we see, okay, errors that could appear is not updatable because a partition column was not found, which means if you're going to insert and the partition column is not actually part of the view, you will fail. Okay, that's one. Then because base table is used multiple times, okay, that's another one. Because what you can actually do with partition views is you can use a table multiple times. There are some use cases, I've seen some, but if you do it, it's not updatable. Okay, so let's see what else. Primary key is not included in the union result. Primary key is not unioned with primary key of predicate if you do not have the primary key in all of them. So there are quite a few errors that could go wrong. But in the end, if you actually manage to get it done, so I try to create a new primary key and then insert again. So it was the identity here as well. And then at the end, finally, I was able to insert it. So like I said, it's a little bit of more work, and you need to consider it while designing your table. It is doable. The question remains just, does it make sense to insert here, or are you going to use your ETL or ELT process to really check which table it should be and then insert into this table? Okay. And as we can see at the end, where is it? We now have one more record. And we can also update this record using this view. We can, so we update and set the ID, no, the sales amount to 10K, which you can see here that actually worked. And at the end, we're just going to remove the entry because we don't need it anymore. Okay, so as you can see, updatable, yes. Hard to configure, maybe. Needs some consideration. Okay. Questions so far? Okay. So we're actually already at the last demo, and for me, it was really the reason why I got into partition views. I was at this one customer who had a tremendous amount of entries in their fact table, and they had performance issues, sure. So what we said is it would be a very good option to use a column store index, because what actually happened is every read required the SQL Server to get everything into memory and page it out again, get everything into memory, because there was just not, there's no hardware on this world that could actually have enough memory to get the whole table in it. So column store, sure, we added a column store index. So we went down from a few terabytes to gigabytes, let's say less than 100 gigabytes. Awesome. Everything was performing smoothly. Everything was performing great. Then after a few days, or I'm not sure if it was weeks or days, the data grew again. So it grew massively. It grew massively. And then we checked and we saw that there was an issue, because if you have a column store index and you remove something, what happens? If you remove something from a column store index, it's not removed. There's just flagged, but it stays. So what they did is they deleted records for the day and inserted them again. Deleted, insert. So they had those massive amount of records that were deleted. That's no issue in a normal scenario, because what you're going to do is you simply rebuild the index and it frees up the space. But with this amount of data, running an index rebuild on a 24/7 machine was just not doable. So what we then said is, okay, it would actually be awesome to have in memory, because in memory is the fastest to insert and update and delete. But now we need to either have a hot table and a cold table, or we just put everything in memory, and that's just not going to fit. So what we did is we created a partitioned view where the hot table contained a lot, was it 7 days or 30 days of data in memory, and everything else just in a column store index, which made their system run very smoothly without a lot of investment. So what we're going to create here in this demo is we create a cluster column store index called on two of those tables. So January, February cluster column store, March remains in the row store. Okay. And then we're going to execute this query. So we're going to select the date ID and group by the date ID. And what we want to have is by day, give us the sum of the sales amount. So what were the sales of each day? We do this for the partitioning and we do this for the partitioned views. There's no in memory here. It's only row store and column store, and the partitioned one is in row store. So which one is faster? How much faster?
Much faster.
Much faster. So actually, with the amount of data I have here, it was 10 times faster. Because you could really see that the column store ones were actually returning the data in less than 0.02 seconds, or even 0.01 seconds. And the clustered index on the bottom was still trying to catch up. So it actually required 7 seconds to get the data, and then another 7 seconds to get the aggregation over the data, which most likely spoiled into the 10 TB. And that for me is one very good reason to have partitioned views, being able to mix column store and non-column store. How many of you have used column store indexes? Okay, so quite a few. So really a very good thing. What we advertise it to be good is it is very good if you want to have aggregations. But I found more than not, it's also good if you don't even have aggregations, because with the amount of compression you get, you can get a lot more pages inside of your memory, which always helps SQL Server performance. But then again, you need to make sure that you do not insert, update, or delete too many records. Okay. So I think I rushed through it a little bit, but if you have any question, feel free to ask. Do you have the chat room?
No questions in the chat?
Okay. Yeah.
I'm just curious, I might have missed something, but you said that you put the recent days data, a few days with the column store index.
No, in a row store.
Sorry, so the recent days were in row store, and the historic data
is in column store. Exactly.
Okay.
That's also what you actually can see here. We have the clustered index and the column store index for January, February, and March is in the clustered index, which is still a lot faster than the partitioning one because data is a third here. But in normal days scenarios, you have not only 3 months of data, you most likely have, normally it's 5 to 15 years or even 20 years if you need to have archiving.
Yeah. So is it good to combine a partition table with a cluster store index? So you have only a clustered index, but you can do also a column store index. So
yeah. So we have a cluster column store index on the let's say data that doesn't change that much, and the normal the row group the row store index, clustered index on the one that changed a lot. But you can still have non-clustered column store indexes as well if you want to. And with the limited amount of data, you're even faster of rebuilding it if you need to.
But I think not in the partition view. Here in the partition table. In the whole partition.
In the partition table, you can't. What you can do in a partitioning is you can have different indexes with filtered indexes, which cover only one partition. What you cannot do is you cannot have different clustered indexes. You cannot have a clustered index over one partition. That's the huge performance gain you get here with partition views.
But you have the column store index on all the partitions in the partition table. You have
only the non-clustered.
Yeah. Partitions.
Only the non-clustered. But if you already have a table which is 10 terabytes of space, and you need to create a non-clustered column store index, that's an additional space, and you do not get the performance enhancement you would get with a clustered column store index. I mean, I don't know the numbers, but I've played it through. It's still a lot faster to go with the partition views in this case. Sure.
How to maintain a system with, let's say, 100 single tables putting together, and then you're getting a new column or some changes on the
dynamic
structure.
SQL.
You have to change everything.
Dynamic SQL.
So you used it because of performance issues, or is this a normal design pattern? Or
no. No, I use it for performance reasons if I need to be able to have a data warehouse that has near real-time data. Otherwise, I mean, it really depends what I would go for. If I know that the data doesn't change, because it's not normal that a data warehouse gets added a lot of fields over time. There might be a few here and there, but you're still able to script it out pretty easily to do direct SQL to add a column. Yeah. Other questions?
Also, if you have something like a rolling partition where you putting automatically a new partition and deleting an old one, and you have a rolling window, it will be very complicated with single tables.
I wouldn't say very complicated. For sure, more complicated than using partitioning, but I think that's something that can be automated quite easily. But I agree, it's more complex in that sense. Yeah. I wouldn't go for the partition view by default, just if the delimitations I've shown are real limitations to your use case. Okay, I think I can close here. Thank you very much for your time, for your close to evening. It was a pleasure.